This video is designed to give you an idea of how scientific notation provides information about the range or accuracy of a number. Remember, scientists are always counting or measuring something, and you can never measure something exactly. So a lot of times the information is embedded in the scientific notation form. So for example, 3 times 10 to the third is the number 3,000. But since they've only given you one significant digit, that is, there's only the leading digit 3, one sig dig, I'll call it. Since there's only one sig dig, what they're really telling you is that they know the number to that column, and they don't know, or they didn't measure it accurately enough to tell you more information. What that means is that they know this number to the nearest 1,000 because the 3 is in the thousands column. So if they know it to the nearest 1,000, what that means is you could be off by as much as 500 higher or 500 lower. So I've written plus or minus 500, which means the highest this number could be would be 3,500, and the lowest this number could be would be 2,500. So let's go back and think about this. Now, of course, when I say the highest it could be is 3,500, what we're actually saying is it's not quite to 3,500. So you could think of that as 3,499.9 repeating. I'm not going to make a fuss over those because I want you to understand that basically what's happening is when they tell you that a number is 3 times 10 to the third, they measured it with enough accuracy and confidence to be able to say, look, it's somewhere in here. It's between 3,500 and 2,500. So for example, numbers that would satisfy this, that it could actually have been, if they were able to measure it more exactly or count it more exactly, it could have been, let's say, 3,486. It could also have been 2,791.2. Any number in the range of 3,500 to 2,500 is rounded to 3,000 when rounded to the nearest 1,000. In other words, if you were more than 3,500 up, you'd be closer to 4,000. And if you were below 2,500, you'd be closer to 2,000 than you would to 3,000. So the single significant digit tells you the accuracy with which this number is known. Look at another example. Let's take something that seems on the surface to be very similar. 3.2 times 10 to the third. This is the number 3,200 when written in standard notation. Now, in this case, we have two significant digits of accuracy, which means the number is known or has been measured or counted to the nearest 100 because that number is written. So if it's written as 3,200, there's reason to believe that it's not more than plus or minus 50 away instead of 500 as in the previous example. That means the high would be somewhere around 3,250, also known as 3,249.9 repeating. And the low would be 3,150. In other words, somewhere in this range, between those two numbers, is where the actual number was if they had been able to count it or measure it exactly. So scientists are in the business of measuring precisely and telling you how precisely they know something, and that's why they're giving you, in this case, two significant digits. I'll write 2 sig digs for short. Okay, and if there are two significant digits, then you know it to that second digit. Let's look at one more example of the same kind of size number. So let's look at 3.26 times 10 to the third. If you write this in standard notation, this is the number 3,260. What that means is you know it to the nearest 10, which means you can go plus or minus 5. So what that's saying is that the high could be 3,265 or 3,264.99 repeating, and the low could be 3,255. Somewhere in there, somewhere in this range, in here, is the actual answer if it was exact and measured properly. So where this gets a little tricky, for one more idea, is if I gave you the following number. If I said that the number was 3.20 times 10 to the third, that is the number 3,200 in standard notation. But because we have 3 sig digs here, we know that they measured it to the tens column because that 0 is written. If this is written, this 0 I've put a box around, then we have measured it to that number. So 0 is just as valid in scientific notation as any other digit, a 1, 2, or 3. It's not a placeholder. It's written there to mean something, and what it means is, once again, we could go up 5 or down 5 without being too far away, which means our high is 3,205 or 3,204.9 repeating, and our low, and this gets a little more challenging because you have to subtract 5 from 3,200, is 3,195. What we're saying is any number in that range, any number between these two numbers in here is what they measured, counted, or understood from their science work, okay? I hope that makes a little clearer sense to start the idea of range in scientific notation.